Assalamu alaikum, Sabah al khair. Hello students, good morning. Welcome to Advanced Computer Networks course. Here first going to course description format. The title of this course is Advanced Computer Networks. The credit is 3, and this is my name, Mehdi Sadeqzadeh, and my email. Prerequisite of this course is network programming and computer networks. Objective of this course: the course is designed for students who have basic knowledge of networking, for example OSI model, TCP/IP, ARP, and few application level protocols, for example local area network, routing, and etc. The course builds its contents by considering a mixed approach of involving theory and practice. From this perspective, the course introduces advanced topics that are basic blocks of networking and covers fundamentals that are used to develop few of the advanced technologies, including, for example, routing protocols, wireless and mobile networks, and etc. The course aims to provide information so that at the end of the course, the students find themselves comfortable in taking either of the direction industrial job or further research in networking. The whole course is designed for 12 weeks of class, 3 hours per week. We start with in week number 1, TCP overview and quick revision today. Week 2, IP version 4. Week 3, IP version 6. Week 5, mobile IP version 6. Week number 6, QoS or quality of service congestion. Week number 7, multicast. Week number 8, MANET. Week number 9, routing. Week number 10, wireless. Week number 11, wireless sensor networks. And week number 12, understanding TCP/IP. Textbook for course is Computer Networks, a System Approach, one of the textbook, by Larry Peterson and Bruce Davis. And another textbook is Computer Networking, a top-down approach featuring the Internet, by James F. Koros and Kate W. Ross. But grading will be one mini project 10%, midterm 20%, final exam 70%, total mark 100. But because here we have in Corona, we have a meeting in coronavirus, we have in change this grading so that 70% for final exam and 5% for present and in class and class activity, and 25% that is belong to seminar. that is, you must select a paper about this subject. For example, QoS congestion, or MANET, mobile attack network, or routing. Here the keyword for this. You can refer to a good journal, for example, IEEE transaction on computer networks. Okay, refer to these journals, and after finding the paper must be after 2007. Old paper not acceptable. You can get DOI. DOI, that is number for paper. When you find the DOI, you cannot download the paper from, for example, IEEE site. After getting the number from this and DOI, you can use from free paper or Science Hub site for download the paper that you give DOI. Then send to me for checking. My email is sader_1999@yahoo.com, or another email in Gmail, sader1999@gmail.com. For approving the paper, if you can accept a paper in a conference or journal, you have additional grade for this. Okay, do you have any question until here? Okay, let me start with lecture 1. That is a TCP overview. In lecture 1 is Introduction to Network Architecture, that is Open System Interconnection and TCP/IP. We use from a slide from Dr. Said Reza Kamel for this part. In this figure, you can see conceptual layering of protocol software. In networks, we use from layer design, so that we have here in this figure n layer. Each layer can use from services that provided by lower layer. Message sent by, for example, here application in this layer. This message reach to bottom layer, and so to lower, until the message reach to layer 1 of the sender. Then sender that is in layer 1, that is physical layer, using the communication medium, send this message to layer 1 of recipient. Recipient send this message to upper layer and upper until the message reach to layer N, so that in layer N message received by recipient. We have, for example, we can say that is communication between layer N from sender and layer N from receiver. But here that is not actual connection, that is virtual connection for protocol. An actual connection in this figure you can see in vertical layer, vertical from one layer to another, and only between physical layer of sender and receiver or recipient we have actual communication. We have OSI model. What is OSI? OSI abbreviation for Open System Interconnection. Okay? Open System Interconnection. This means any system with different hardware and different operating system can communicate with another computers so that obey from network standards. This means this model can connect heterogeneous, not homogeneous. Heterogeneous system can connect heterogeneous systems to each other. OSI model is a layered framework for the design of network systems that allows for communication across all types of computer systems. This means communication across all types of computer systems. This means all computer systems with different hardware and different operating systems can communicate with each other if obey the standards, if the obey of network standards. In this model, we have 7 layers. From bottom to top: physical layer, data link, network, transport, session, presentation, and application. In this figure, we can two hosts, host A and host B. In host A, we have 7 layers. Application of host A send message to presentation layer with interface between 7 and 6 layer number 7 and layer number 6. Presentation add header to it and send to session layer with interface between layer number 6 and number 5. And this continue until message reach to data link. Data link gets data from network layer from interface between layer number 2 and number 3, added header and trailer to it, and give to physical layer. Physical layer send message from the network, so that here we have a router. Router have 3 layers: physical, data link, and network layer. And the router give the message to another router until reach to the receiver. Receiver is host B. Physical layer of host B get the message and give the message to data link. Data link get header and trailer of this message, of this packet, or this frame, and use from, for example, trailer for checking that message was not corrected under transmission, and get remainder of this to network. Network get the header of it for routing and give remainder to transport. Transport use from header to flow control and get remainder go to session. Session give the to presentation, and presentation give the message to application. In this figure you can see protocol layers in the ISO open system interconnection model. Open systems interconnection. This means different computer can connect to each other from this model. What is ISO? Do you know what is ISO? Yes, international standard, okay, organization, ISO, international standard organization. That is organization for producing a standard, so that OSI, that is Open System Interconnection Model, approved by ISO, International Standard Organization. So, in this figure you can see we have 7 layers. Application layer, message sent by application layer, give to presentation, then session, transport, network, data link, and physical layer. Physical layer of sender send from communication medium. Communication medium may be, for example, wired or wireless, okay? To recipient. This is a physical layer of recipient. And physical layer of recipient send to data link, and then network, transport, session, presentation, and finally application. And message received in application layer of receiver. In this figure, more details of this transmission showed. Exchange using the OSI model. You can see we have L layer 7 data, that is application layer. Send data to presentation. You can see presentation added header to this data, to this message. Header of layer 6 added to header of this data, okay? And give to presentation, session. Session give layer 6 data. Session get layer 6 data, that is data from presentation layer, and added header 5 to it. This is header of session, okay, and give these to transport layer. Transport layer give get data from layer 5 session and add header of layer 4 to it. This is header of transport, and give the message to network layer. Network layer added header of this layer to it and give to data link layer. Okay, data link, you can see added header to it, to head of it, and added trailer to it, to trail of it, and give to physical layer here. Physical layer, no added any header or trailer, only transmission from network. For example, here 0, 1, 0, 0, 1, and so. Send this message to recipient. Recipient get this message and from physical layer and give to data link layer in receiver. Data link layer get the header and trailer of it and give the message to network layer. And this work continue until the data delivered to application layer in receiver. Okay. And figure, yes, and figure here, it is layer 1, not layer 0. Here layer 1. Yes, here layer 1, here not layer 0. This means signal, for example, here 1, here 1. Then 0, 1, 1, 1. This signal 1, 1, 0 show with signal. Here not layer 0, that is layer 1. Layer 1, layer 2, layer 3, and other. Yes, we use from header in data link layer, header for flow control, header in data link for flow control, okay, and trailer for error control. For example, CRC, cyclic redundancy code, that is in trailer of data link. CRC is computed from data and attached to the message. Yes, for checking, for error checking. Trailer for error checking. Header for flow control. Flow control, this means if, for example, number of packets is sender is more, so that receiver cannot process it, and we have congestion. So that one of the tasks of data link layer is flow control. That is rating of sending frame to another, because when we have in data link layer we have frame. But when we go to network layer, we have packet in that layer. And trailer, that is for error checking. Error checking means we must know the message delivered in the destination be the same message that sent in sender. Okay. In this figure, you can see encapsulation as it is applied in layer protocols. Encapsulation means using from upper layer in sender, get an added header or trailer to it, but encapsulated in package. Here, application layer message, you can see, give the message to presentation. Presentation added presentation header and give to session layer. Session layer add session header to it and give to transport layer. Transport layer give to session header. Session layer give this message to transport layer. Transport layer added transport header to it. You can see. This means that the size of message will be bigger and bigger. And transport layer give the message to network layer. Network layer added network header to it and give to data link layer. Data link layer added header and trailer to it and give to physical layer. But in this figure, you can see first 3 layers in OSI model. This means layer number 1, number 2, and number 3. In layer number 1, physical layer, we have interest to physical interconnection to network. For example, here you can see coaxial cable and T connector. T connector, you can see T, like letter T of English, okay? T. Connect the network card of computer to network. For example, like Ethernet network, that is local area network. Or for example, using from fiber optic, or using from twisted pair here, or using from wireless communication. In data link layer, we discuss about, for example, network card and modem. Here, that is network card that insert in a slot of computer, okay, on motherboard. This card is, for example, responsible for control, flow control, and error control. And for example, this is modem, and or switch, here switch, and this is the modem. And in network layer, we discuss about routing protocol. For example, here we have router, and here, for example, we must determine the routing path between different computers. For example, here A, B, this rectangle, that is computers, and this circle that is router. And in operating system, for example, Windows XP, Windows 7, 9, and other, you can set the, for example, IP for each node or each router, and can setting these parameters. or for example means gateway, for example gateway number. If you compare the TCP/IP model and OSI model, in the left figure you can see OSI model, that is 7 layers, okay? But in TCP/IP model we have 4 layers. Application, that is equivalent with application, presentation and session layer in OSI model. And transport and internet and network interface. In transport layer you can use from TCP or UDP, transport control protocol and the unidatagram protocol. Here you can see another figure of TCP/IP model. We have 4 layers: network interface layer, internet layer, transport layer and application layer. In network interface layer you can use from different protocol, for example Ethernet, that is bus-based local area network, or point-to-point protocol, that is asynchronous communication or modem, or frame relay. Frame relay, that is a protocol that consider quality of service. Quality of service. What is quality of service? For example, when buffer of router is full, only the packet with lower precedence will be deleted, and packet with high priority not deleted. Frame relay consider the priority between different packets. And ATM, that is asynchronous transfer mode, that is protocol that used in networks, in not computer networks, in telecommunication networks. In internet layer we can use from internet protocol and ICMP run on IP. You can see here ICMP is internet control message protocol. In transport layer we can use from TCP, transport control protocol, or UDP, unidatagram protocol. TCP, TCP is connection oriented protocol, okay, while UDP is connectionless protocol. This means in TCP we need to overhead for starting communication, and after send and receiving data we need to disconnect connection, and all packets from one source to one destination give from one path. But UDP is connectionless protocol. No needed to start connection and disconnect connection, and there is no single path from one source to one destination. This means packet from one source to one destination can use from different paths. Okay? Do you know IP is connection oriented or connectionless internet protocol? What is the type of IP protocol? Connection oriented or connectionless? No. IP is connectionless. Yes. IP is connectionless, not connection oriented. And in application layer we have different protocol. For example, telnet or remote login. You can use from this protocol to attach to remote server, so that you can, if you have user and password, you can use from it. FTP, file transfer protocol, for transmission file between computers. SMTP, simple mail transfer protocol. Simple mail transfer protocol means only email text, not for example multimedia and video. DNS, domain name service. Domain name service for example giving the URL and getting the IP address of that server. RIP, routing information protocol. And SNMP, simple network management protocol for managing the network. And here you can see TCP/IP layers. We have application, transport, internet, and network interface layer or network access layer. Application send message to transport. Message can be UDP or stream TCP. Give to transport. Transport can use from UDP or TCP packets for sending. If used from TCP, that is stream, because all data give from one source to one destination from one path. And give to IP. IP break UDP or TCP packets to datagrams, to IP datagrams. You can see to a small division, and give to network, underline network, for sending this frame. Here network a specific frame. And encapsulation in message transmitted via TCP over an internet. You can see TCP or UDP. Here application message give to TCP, give to transport layer. Transport layer added TCP header to it. Okay, and TCP header and port added to it. Port, for example, each application have different port number. For example, FTP from one port, HTTP from another port in application. TCP header, TCP added TCP header to it, give to network layer, that is IP. IP added IP header to it, and that is TCP. Why this is? Application message when give to TCP layer, TCP added port number here and added TCP header, and IP added IP header and here TCP. Why? Because if, for example, UDP send this message to IP, the IP here added flag UDP here. But why here TCP? Because the upper layer here is TCP. And give to network, give to network access layer. Network access layer added Ethernet header to it. And here IP, that is in upper layer used from IP. And give to physical layer. Ethernet frame can be transmitted by physical layer. Why the programmer's conceptual view of TCP/IP in internet here? Programmer work on application layer here, okay? And then programmer can use from TCP function or UDP function. And if he or she use from TCP or UDP function, TCP or UDP can use from IP layer, that is beside it. So we have, for example, different function for TCP and UDP. For example, DCP function used from TCP. TCP function for connection, for example, in Unix. This is different with UDP function. Here, for example, here. This is function for UDP and TCP. Yes, here. Int socket, int family, int type, int protocol. Okay, that is a function. Family means, for example, in IP versions for IP version 6, Unix domain, routing, what? Type shows no type of socket. Socket stream, socket datagram, sequence packet socket, row socket, and protocol means number of protocol used. For example, for TCP, protocol is IPP route TCP. For TCP, here. For TCP, you use from this, but for UDP, you can use from IPP route UDP, and you can use from SCTP, for example. You can use from different here. Okay, the third parameter in this function different based on the type of your protocol you use. Okay, and after creating socket, you have bind. You can use from bind function, and for example, server use from listen, and client use from accept function. And after this, you can use from send receive function to client to server, from client to server. For more information, you can see here. For more information, you can click on this URL. You can see detailed of this program for sending, for example, request to server. This TCP client send request to server in three-way handshaking. In three-way handshaking, you can client can connect to the server. Three-way because client send to server SYN and server acknowledge with SYN and acknowledge, and client send acknowledge in TCP. So that in TCP we need 3 message for start connection, but in UDP we don't use to start connection. Okay. Do you have any question until here? Do you have any question until here? Okay. We have 50-minute break and then continue. Thank you. We continue to this lecture, students. In network access layer, that is lowest layer in TCP/IP protocol, We have a standard IEEE 802 network standards. In this table you have seen different standards. In first column IEEE number, second name, third title, and other reference. For example, IEEE number 802.3, that is Ethernet. Ethernet used from CSMCD protocol networks. What is CSMCD? Carrier sense, multiple access, collision detection. Okay? Carrier sense, this means each computer, when one send a message to another computer, wait for carrier. Multiple access means different computers can send message, but in any time only one computer can send message, and that is maybe we go to collision. When collision occurred, you know? When collision occurred? Yes, collision occurs when, for example, two or more computers want to send a message on the bus. Okay, this collision. When collision occurred, no computer can send a message. In a random time, after that, each computer can want send message earlier, that is win. 802.4, that is token bus networks. 802.5 token ring networks. Here in this network, use from token. Each computer can get token, can attach the message to this token and send to next node until the message reach to the receiver. 802.6 metropolitan area network, that is in city area. 802.11 Wi-Fi wireless local area networks. 802.15.1 Bluetooth wireless personal area network. The Bluetooth, for example, range in between, for example, 2 until 30 meter. 802.15.4 Zigbee, that is wireless sensor networks. In, for example, Internet of Things networks, we can use from Zigbee protocol. And 802.60 WiMAX, wireless metropolitan Metropolitan Area Network, that is WiMAX, with more range related to Wi-Fi. Here you can see, for example, WiMAX that is more range related to Wi-Fi. Here, for example, in network performance, we have wired or wireless networks. Example, range, bandwidth, and latency. In local area network, wired. For example, Ethernet, that is range between 1 until 2 kilometers. Bandwidth between 10 until 1000 megabit per second, and latency between 1 until 10 milliseconds. WAN, IP routing example in worldwide range between 0.1 until 600 megabit per second, and latency 300 until 1500 milliseconds. MAN, Metropolitan Area Network, for example, ATM, ranging 250 kilometers. Bandwidth between 1 until 150 megabit per second, and latency 10 milliseconds. Latency here is low, so that the ATM is a good networks with high performance, but the more cost. Internet networking, for example, internet worldwide, bandwidth between 0.5 until 600 megabit per second, a latency between 100 and 500 millisecond. Wireless network can be wireless PAN, personal area network. In wireless, for example, Bluetooth, between range 10 until 30 meter, bandwidth 0.5 until 2 megabit per second, and latency between 5 and 20 milliseconds. Wireless LAN, for example, Wi-Fi, IEEE 802.11, range between 0.15 until 1.5 kilometer, bandwidth between 2 until 54 megabit per second, and latency between 5 and 20 milliseconds. Wireless MAN, that is WiMAX, is 550 kilometer range. That is very more than Wi-Fi, and bandwidth 1.5 until 200 megabit per second, and latency between 5 and 20 milliseconds. And wireless WAN, for example, GSM and 3G phone nets and 4G and 5G, ranging worldwide, bandwidth between 0.1 until 2 megabit per second, and the latency between 100 until 500 milliseconds. What is GSM? Do you know? Yeah, GSM is the Global System for Mobile Communication. That is a standard for mobile communication. Global System for Mobile. And IP layer. Orientation is IP layer or Internet Protocol is a network layer protocol. You can see here. In network layer, we have IP protocol and can communicate with ICMP, Internet Control Message Protocol, and IGMP, Internet Group Message Protocol. And upper layer, transport layer, can use from TCP and UDP, can communicate with and use from IP service. And in link layer, we can use from network access or ARP protocol. And network access connect with media. ARP, what is ARP? Do you know? What is ARP? Address resolution protocol, yes. Address resolution protocol, that is convert MAC address to IP, okay? And IP address to MAC address. Because for example, in local area network, we don't need to IP address, and computer can detect it and identify each other by MAC address. IP's current version is version 4, and it is specified in RFC 891. And now we can use from IP version 6. In application protocol, IP is the highest layer protocol, which is implemented at both router and host. We can see here. In a host, we have application, transport, control protocol, IP, and data link. We have 4 layers. But in router, that is between them, the highest protocol is IP in the router. IP is the in network layer. So that you can see, for example, router IP protocol. In router can communicate with IP protocol in host. And IP protocol in the left router can be communicate with IP protocol in right router. And IP router in this router can communicate with IP protocol in right host. This is destination. So that is, for example, between data link of host and data link of router, we have connection. But here, not physical connection. This is virtual connection. And between IP of host and IP of router, and between of IP of left router and IP of right router, or between the TCP of host and TCP of another host. It is with TCP protocol can communicate it, but these are virtually, not actually. Actually, that is vertical. Application sent to TCP, sent to IP, sent to data link. Physical communication, that is on physical layer. Okay. Here, routing in a wide area network, you can see. For example, we have here 5 routers here, A, B, C, D, and E. Here we have 5 routers. And these are host or local networks, can communicate with each other from routers. For example, what is the path? For example, this host can communicate with this host. We use from 2 routers, for example, A and D. the router A and D, these two networks can communicate with each other. Router A, for example, we have two links, 1 and 3, connected to another routers, and one link to network. B has 4 link, C has 2 link, E has 3 link, as D is 2 link. For example, when A wrote another packet to D, use from link number 3, you can see here. So that we have in this figure 1, 2, 3, 4, 5 routers and 1, 2, 3, 4, 5, 6 road between routers. Here you can see routing table for this network. For example, routing table for from A to A, that is link in local, so that is no cost. And when from A to B, the cost in 1 from link 1. Come back here. A to B, you can see from link 1 and cost is 1. Okay. A to C, what is the cost? From A to C, what is the cost? Cost 2, because first A to B and then B to C. Okay. So that from A to C the cost is 2 because we need 2 steps, but link is 1. Okay. Here A to B, A to C, A to C, use from link 1, but cost is 2. Okay. A to D, come back. A to D cost 1 because in 1 hop, and link use is 3. So 1 to D, use from link 3, but cost 1. And finally A to E. How many roads from A to E? Yes, cost 2. But we can use from A, B, E, and another A, D, E. Okay? We have 2 costs from A to E, A, B, and A, D. This means use from link 1 or use from link 3 with cost 2. Here, A to E cost 2. Here, for example, link 1. But we can use from link 3. Okay? Link 1, this means ABE, you can see. Link 1. Link 3, ADE. So that you can use from another routing table and check it. IP service. IP provides an unreliable connectionless best effort service, also called datagram service. That is unreliable because IP does not make an attempt to recover lost packets. Maybe packet may be lost. Connectionless. This means each packet datagram is handled independently. IP is not aware that packets between hosts may be sent in a logical sequence. And best effort. This means IP does not make guarantees on the service. For example, no throughput guarantees, no delay guarantee. For application, for example, for multimedia application, we need 2 guarantee. For example, we have need 3 frame per second, okay? For film, 30 frame per second, 30 frames per second. If number of frame low than this, that is not good service. So that IP don't guarantees the quality of service. Consequences, Higher layer protocol have to deal with losses or with duplicate packet. Duplicate packet, that is packet sent twice, and packet may be delivered out of sequence because the IP service is connectionless service, okay, not connection oriented. Here IP support the following service one-to-one. This is unicast. You can see in this figure one source and one destination. One to all, that is broadcast, one source and all destination others, and one to several, that is multicast, one to several. You can see that is this message, for example, sent to members of this group, that is multicast. IP multicast also support many-to-many service here, for example 1 to 3 here, and for example another to another, can support many-to-many. IP multicast requires support to other protocols, for example IGMP, Internet Gateway Message Protocol, and routing, so that we can use any cast. Any cast include unicast, multicast, and broadcast. IGMP, I send you Internet Group Management Protocol, IGMP. Internet Group Management Protocol. IGMP or Internet Group Management Protocol is a communication protocol used by hosts and adjacent routers on IP version 4 network to establish multicast group memberships. So that is protocol in between routers. For IGMP is an integral part of IP multicast and allows the network to direct multicast transmission only to hosts that have requested them, not for others. IGMP can be used for one-to-many networking applications such as online streaming video and gaming. This means one-to-many IGMP, for example, one sender, some receiver, and allow more efficient use of resources when supporting these type of applications. So that Internet Group Management Protocol. Okay, let me now upload these files so that you can download it. That is syllabus, and that is lecture 1 that we speak about it here. For next session we go to lecture 2 and speak about IP version 4. We can download it from here, this file. Let IP version 4 so that you can hear. You can pre-study this lecture. Okay? Do you have any questions, students? Okay, because today is Friday, I have hello to Imam. Assalamu alaikum ya Abul Hassan al-Askari. السلام علیک یا ابا صالح المهدی. خدا نگهدار.